Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, here at your kitchen table in Amherst for some kitchen table astronomy and some film critique, as you are on the board of the Amherst Cinema, which is one of the places you can see Martin Scorsese's new 3.5 hour long epic film, Killers of the Flower Moon. It says moon in the title, so astronomy is related to it. Another natural tie-in here. Before we get into what we're going to talk about astronomy-wise, which is free-floating planets, which I thought we were all free-floating, how was the new Scorsese movie?
So this is really interesting. Thank you, Monte, for bringing the moon part in it, because I was racking my head. I was like, can I tie in some science fiction reference, some sort of like the Martin Scorsese? Has he done anything in the past? And I was like, no, it's really hard. But I really wanted to say, please go and see this film. Yes, it is long. It's 3.5 hours long. And I wish it was a little bit longer.
Wow.
Because the story is amazing. It immerses you. It's tragic. It's about Osage tribe in Oklahoma, which actually, again, I'm not giving too much away, but it's like they struck basically oil over there. They got very rich. And they were moved from Missouri. That was the whole thing. They were sent into a place which would have nothing, and they got oil. But then around them, a lot of the people didn't like the fact that Native Americans were rich. And the story is about what happened around that time. This is set in the early 1920s. You also have Tulsa race riots at the same time, and so this is a really important film. I think this is one of the best Martin Scorsese films, which is saying a lot. Of course, Raging Bull or Goodfellas. There are a lot of other films, Taxi Driver. But this is, again, I was not a big fan of The Irishman.
Me either.
But it seems like a personal film to him. And representation-wise, I think he has taken a lot of care to tell the story right and to place it in the context of the native tribe as well. So, I know it's 3.5 hours long and people are going to I don't want to go and see it. No, go see it. This is an important part of American history, a part of American history that is often and had been ignored, had been covered up. But I think I'm so glad that it is being it is now being part of a really amazing film.
From the flower moon to our moon and other things in outer space, what are we talking about astronomy-wise today?
Well, so James Webb Space Telescope, that's an easy thing, sort of
every day something the James Webb Space Telescope
I'm tired of James Webb. Oh, no, we're not.
Never be bored before stars.
No, so it is a new instrument. And so whenever it looks at places, it's telling you something that's different. This is new. And recently it looked at one of the most beautiful objects in the night sky, and that is the Orion Nebula. And so it is a winter sky object. So soon it will be sort of in the evening skies in a few months. But right now, if you can stay up a little late, you can actually see it. It's part of the Orion constellation. But below the Orion's belt, there is Orion's sword. And there you have a fuzzy patch. If you have a binocular or a small telescope, you can see that. And the reason it is fuzzy is because it's a nebula. It's a gaseous sort of cloud in which a lot of stars are forming. And if I can, I know it's radio part, so I cannot show you what my hands are doing, but the actual, the full cloud is actually much bigger than the full moon, the area that it covers. In fact, double the size of the full moon. But this Orion Nebula is a tiny part where young stars that have already formed, these are big stars, because of their light and radiation, they have, in some ways, blown a cavity through it. And you can actually see inside the nebula. So that is actually really cool, and it has beautiful colors. If you see pictures of it, it's reddish in color. James Webb Space Telescope also has a beautiful image in there. And it's a stellar nursery. So you have young stars. It has been studied a lot. Perhaps the most studied nebula in the night sky, because it's relatively close. It's about 1,300 light years away. And so we know if you want to study stars, you can look into that. But as I mentioned, as I keep on mentioning, it's a gas cloud. It's a gas and dust is in there. So with visible light, it's actually hard to see through the cloud or what is going on in there. But James Webb Space Telescope looks in the infrared, and it can pierce through some of that clouds. But what it found is something that we had not even expected. And what it found was about 540 free floating objects, which are closer to the size of Jupiter. And
So most planets, or these free floating objects, are in an orbit around a star, a solar system. These are free range planets.
right, so astronomers have discovered some of those before, but they have found them and they think that those were ejected from a planetary system. So if you have a solar system, so that's how we think planets form, that when a star is forming, around it there is a disk. It's called protoplanetary disk, and there some parts of that coalesce, some material coalesce around it, and it forms into planets. Big ones, Jupiter, Saturn size, and then small ones as well. And so when astronomers have found some of those free floating planets, meaning to say planets without a star, they thought that, well, they got ejected from from the star system, and they formed in the same way. But here, it's about 9% of these planets they found, the James Webb Space Telescope, are actually binaries. They are orbiting each other. And in fact, astronomers who discovered them, they actually called them jumbos, Jupiter mass binary objects.
I like that. That's a good name.
That's a good name.
Yeah.
Dumbo would have been even better, but no.
Jumbo shrimp?
Yeah.
No, maybe, I don't know.
So jumbos. And so that really forces you to think, wait a minute. Now, they would not have been ejected as a binary system. And that really forces us to think, how were they formed? And it's not just it could have been a random alignment, because but in astronomy, when you are taking a picture, you're just taking a picture of it, right? So you can have, maybe they are not exactly orbiting each other, but maybe they just happen to be close in sight. But astronomers think, people who discovered those, that for that you would have expected a couple of percent, maybe 3% or so, to be just statistically to be in the appearance of binary. But here you have 9% of those. So they think actually these are real binary planets, and these are Jupiter sized. And it looks like they may have formed that way. And Monte, you would say, but wait a minute, but how did they get formed? We have no clue.
Wow.
Because people did not expect it. People thought, so there are some substar objects which are called brown dwarfs. Brown dwarfs are objects that are about 13 to 15 times bigger than the mass of Jupiter. They are not called stars because you don't have hydrogen fusion in it. In fact, there is deuterium fusion that heats them up. But below that, astronomers didn't think that you would find objects that are by themselves, and they formed by themselves. But now it seems like there is a whole range of objects that keep on going in smaller sizes. And there is a very intriguing idea of how they might have formed. So as I mentioned before, one idea is that they got ejected. Somehow they found each other, and they got into a binary orbit. A love story. But
It's like a same-sex love story, because instead of having a star and a planet, it's two planets. I'm kind of like moved by this.
That's right. Except that it looks like that may not be. I mean, it's very unlikely. Okay. But what one idea is that these were actually going to be stars. But remember, I mentioned that big stars have sort of like excavated a cavity in the cloud because of their radiation, because they have a lot of ultraviolet radiation. So they actually evaporate gas. So one thing they do, which we knew beforehand, is that these big stars, when they form, so they themselves have formed, and their radiation actually starts to evaporate some of the gases in the nebula in which they were formed. And that can actually stunt the growth of other stars that are forming. So we knew that sort of like it doesn't let other stars to keep on getting gas to become bigger, and they can stop their formation, or they can stop them from being bigger.
Now it's like the secondhand smoke of planet formation. I like the same-sex marriage version better than the secondhand smoke version of it.
But here is the case. So in this particular case, one idea is that these were stars, and half of the stars that form are in binary systems. I mean, our sun is sort of like just by itself, but half of the stars are in binary system. So one idea is that these would have become binary stars, except that those bad, meanie, big stars,
Smokers.
they actually avoided them becoming a full star, and now they are basically binary planets, Jupiter-sized planets. In fact, some even smaller than that. So that's a fascinating thing. Why is it sort of like, interesting? Well, we didn't know these existed. And the reason James Webb Space Telescope could detect them, one, because it could peer through the gas and dust, and also because these planets are still young and they have quite a bit of heat inside of it, which actually emits in the infrared. So they are not reflecting. That's one of the reasons why just free-floating planets is really hard to detect, because planets, usually the way we detect them is by their reflected light. Here, in this case, they actually have 1,000-degree temperature, for example, inside of them, because they are still young, and James Webb Space Telescope could actually detect them.
Even though we've looked at this Orion Nebula so many times since the invention of telescopes, probably, this is all brand new information just because of the way James Webb works in this infrared spectrum, as opposed to the other, the way that other telescopes work, the Hubble telescope, for instance.
Right, and you also need very high resolution. So we had infrared telescopes, but you need to identify these dots in the nebula, and James Webb Space Telescope can do that. So apart from infrared, it also has high resolution. And this is the beauty of these kind of instruments, that you point the same instrument that humans have looked at, sort of like, all the way from post-Galileo, right? Interestingly, Galileo did not note, I think he did not note the Orion Nebula, but soon after, actually, people had seen, hey, what's that fuzzy
Fuzzy up there?
And it had been noted before. Of course, they didn't know the nature of those objects, but you can study a lot, but you look at it from a different wavelength, different type of light, different type of telescope, and you learn new things. But there is another interesting thing that maybe you can think about it, and that is our sun formed in a nebula similar to the Orion Nebula. And so in these kind of systems, you form several thousands of stars in it. And our sun, we don't know where the siblings are, because over 4.5 billion years, we've all spread out and stuff. But our sun formed in a similar type of system. But that means that there may be many, many, many more planets that are distributed in the galaxy, which we don't see because they don't have a star next to them. And that is an interesting thing. I was thinking sort of like, that, okay, humans talk about potentially going to other stars, and you go like, oh, even Proxima Centauri, it's about 4 light years away. That's quite far. But there may be planets in between. Maybe they can be planet hopping, sort of like, we can actually find these objects, these bodies. If we get better in terms of detecting them, it will be very hard to detect, but maybe we get some other, in the future, telescopes to detect them. Maybe there are many planets around it that are available for planet hopping too close to get to a star system. We can get sort of like, in there. And then the other thing I was thinking was, now that we know moons around planets like Jupiter can have water on it, and that has to do simply with the way you don't need the sun. That light, the heat doesn't come from the sun that makes it water, but rather sort of like their orbit around the giant planet. And you can actually have the interior that has liquid water ocean, like Europa or Ganymede, or for Saturn's moon Enceladus or Titan. Maybe there are all these planets out there which have moons around them. And I don't know. I'm going to leave it next. We think right now that for complex life, for intelligent life and things like that, you probably need solid surface and things like that. Who knows? But it just opens up a whole class of objects that may be filling up the galaxy between stars we don't know them, and here they are. They exist. But we now, with James Webb Space Telescope, we at least know they get formed. They get formed in a star system, and Orion-like systems are aplenty. And most of the stars, like our sun, formed in such a system. So there must be planets like these as well.
Just when you think the Orion Nebula has done everything good that we could possibly learn about it, it has a couple of fizzled out movies like The Irishman. Lo and behold, late career, amazing work from the Orion Nebula.
That is absolutely correct. So the final lesson is, please do go and see Killers of the Flower Moon and see it in the theater, because it is also a beautiful film.